The height times the width.
Perfect. So that's just one of the areas, and if this is a rectangular cube, then we have the same properties of this rectangle, right? So you knew that this width was this width. So if you know that the area of this face, do you know the area of any other face?
The one opposite, yes.
Right, so we know the one on the opposite side, so we'd have a repeat, right? So just like right here, where we have 2 of the width, we're going to have 2 of that face as well. So we're going to repeat this with every combination, and because it's a rectangle, we're going to have repeats on the sides and the back, and the top and the bottom. So here we have surface area, which is all 6 faces of this rectangle added together. Very similar, using the same properties as over here, where we have the properties of the rectangle, which help us find the properties that we're looking for. Cool. So what's another property of this second shape that we could find?
The volume.
Volume, good. So how would you find volume?
I don't know. So we'd have to be using the same thing that you applied on the first one.
Right, so let's think of this real fast. So perimeter over here kind of had a little bit of a connection with surface area, right? So it's finding these external, these outside walls of sorts. So if area were to connect with volume, and area was length times width, what do you think volume would be?
Length times width times height.
Perfect. Let me check something really fast. Hang on. 11%. Okay, I need to plug this in. This is a very smooth transition. Very smooth, very smooth. I'm sure this will come up great on the feed. Real fast. Okay. Come on. There we go. Okay. Let me just... Okay. So we good again?
Yep.
Cool.
Ready to go.
Cool. So yeah, so we have volume set as length times width times height. So for a rectangle, that's a very easy thing to do, right? You have your 3 dimensions, you're set. So sometimes we have some more complicated shapes, like I'm going to show in a second, and a few tricks behind maybe how you might manipulate what you have to find out information that you need. So, this real fast. So here we have something that looks almost like a square right here, right? So let me just shade this in. So we have this square. On top of this square, we have this triangle, kind of, right? And this is kind of being pushed out, extruded out. So typically you would do, we want to find volume. Say that's end goal. So typically length times width times height, right?
Yeah.
Okay. So if I call this length, okay, and that width, what do we call height?
Well, there's 2 different values.
Well, so we have this piece right here,
Right.
this taller piece right here. We also have this sectional piece right here.
Right.
So if we were to have that, what would you say height would be? Or is there a specific height? Is there a right answer?
Well, there doesn't, unless you could break it up maybe as a rectangular cube and then break it up again as a triangle.
Perfect, right. So let's go ahead and let's do that. So let's give this some dimensions. Let's say the entire height of this thing is 40, and the width of this thing right here is 20. And right here, let's throw this as, say, 10. And let's give one more dimension. We'll call this 20. We'll make it nice for ourselves. So in here we have that this square that you were saying before is 20 by 20, right?
Yeah.
Cool. So right here we have 400 for the area, right?
Okay.
Cool. So we would typically take this, right? 20 times 20 times the 10. That was your idea? And have that longer rectangle? Okay.
Yes.
So let's hold on to that for a minute, and let's just find the area of each first.
Okay.
But real fast, you did the 20 times the 20 times the 10, right? So without the 10, what do you have? The 20 times the 20, what do we call that?
The 20 times the 20 is just the one surface area.
Right, so it's just that area, that surface area right there.
Yes.
That surface area times our depth, that gave us the volume.
Okay.
So we're going to use that same idea. We're going to find the surface area of the triangle times the depth to give us the volume. And then ultimately we're going to see, we'll have the entire surface area times the depth to give us volume, to try to connect the two ideas. So if we have this triangle, which we can bring over here to make it a little easier, make that a little cleaner. So we know the bottom is 20.
Yeah.
So we don't know the hypotenuse. We know this is a right angle. Do we know this side at all?
Probably 20.
Probably 20. Where do you get that from?
Actually, I don't know that. I was just looking at the diagram, thinking that.
Well, good.
Well, it's 40 from. Yeah, it has to be 20.
Good. You're right. So if this height right here is 40, so is this height. And if we already have this cube, we already have 20 removed from that height, leaving that 20 left over.
Correct. Yes.
And for the sake of time, through the Pythagorean theorem, we'll find that the hypotenuse right here is 20 root 2. And a quick reminder real fast, if we have a triangle, A, B, and C, how do we relate these three sides to Pythagorean? What's the formula?
A squared plus B squared equals C squared.
Perfect. Exactly. Just as a quick refresher. Okay, so we have now a triangle with its dimensions. So what is the area of a triangle?
I don't remember.
No? Okay. So the general formula is 1/2 the base times the height. So for our example, what would be our base?
20?
20, good. And what would be the height?
20.
Good. So ultimately here we have 10 times 20, so 200 for the surface area.
Okay.
Good. So now we have this shape, right, which is simply something of this form in total.
Yeah.
And we have that the top triangle is 200 and that bottom square was 400. So combined, our surface area is 600.
Right.
Right. So just like we did with the square, if we were to look at the volume of that, it'd be length times width times height or depth, or the third perimeter, or third dimension. And so for here, it'd be the area times that depth. Same if it was just the triangle, and same if we were to combine them. So if we were to combine them, we'd have that 600 times that 10, which would give us a total volume of 6,000.
Really?
So if we were to generalize this, we have that the volume, given a shape that has length and width and height, right? So length, width, and height. If we were to kind of isolate the length and width, we typically call this what? So before we called it in our first square, we called it just area, right?
Yeah.
And then we bring it into the 3D, we take this length times width, and instead of calling it area, it's called something very similar, which is?
You broke up a second, sorry.
Oh, so we have that before we used to call the square, we used to call the length times width the area. We bring it into the 3D, and we instead of calling it area, we call it something else more specific.
I don't remember.
The surface area.
Surface area.
Right,
Yeah.
so because we don't know which surface, we're going to find the area of.
Okay.
So another way we can write volume is going to be the surface area times the height, or the depth. And in this sense, we were able to take this, which doesn't have a specific length, width, and height, and break it into the multiple shapes to find our surface area, and then extrude that into the 3D. So we can do that with any collection of shapes. We could have